Welcome once again to Mathematics Meal. Mathematics Meal is part of Mathematics and Science Meal program where we use Simplified method in teaching students mathematics and sciences. Today on Mathematics Meal, our business will be on fractional indices. We are still on this business. Remember, in the last video we saw the meaning of fractional indices and the steps in simplifying fractional indices. We also saw the basic rules that are involved in fractional indices. So today we want to start solving examples of fractional indices. So let's go together in these examples. We have example number 1. The steps that we listed in our last video, they are still with us here. And I asked you to make a copy of those rules. Remember the rules. Yes, make a copy of the rules. So if you did not watch the previous video, there is need for you to watch that so that you can flow with us in this episode of fractional indices. So let's get moving immediately. So we have to simplify 16 raised to power 1 over 2. Very simple. So we just needed to use this to start as an advertising. So we say, if we want to simplify fractional indices, what do? We take this step. Take note of the term or expression. We have taken note of this. They say, using appropriate rules or law, remove the negative sign on the power, if there is any. In this case, we don't have any negative sign on the power, so that this step will not be applicable. So we leave this step and move to the next step. And what is the next step? Write the term in root power form. This is the main thing in fractional indices. The ability to write the term in root power form. And so how do we do that? We said in our previous video that the numerator of the fraction is the power, while the denominator is the what? The root. That's what we state here in bracket, that in fractional indices, the numerator of the fraction is taken as the what? The power, while the denominator is taken as the root. So if we write this now, 1 becomes power of this, while this 2 is the root of this. So we're going to write the square root of 16 raised to power 1. So we have written this now in root power what? Root power form, root and power form. The 1 is the power, the 2 is the root. So this sign we introduce is to take care of these two. Remember, when you write square root, you don't need to indicate any number. You don't need to. If it is cube root, you can say cube root of 27. You see this? But once it's square root, when you are writing the square root symbol, you don't need to indicate 2 here. I know, we know that from the origin. So we now say, once you have written the term in root power form, the next thing is to evaluate the root, then the word power to obtain your answer, or evaluate the power, then the root to obtain your word, to obtain your answer. So we can evaluate the roots first. What is the square root of 16? Square root of 16 is what? 4. We just evaluated the root. The power is still 1 here. So 4 raised to power 1 is 4. Alternatively, someone can say 16 raised to power 1 is 16. So we decided to evaluate the power first by saying 16 raised to power 1, 16. We have cleared the power. The root is still there. So square root of 16 now is what? Is 4. Is 4. So we have this as our answer. So this is simple. Generally, please take note of this. Generally, when the power is a fraction, when the power is half, it's talking about square root of the word of the base. So if I have 9 raised to power 1 over 2 is square root of what? 9. 4 raised to power 1 over 2 is square root of 4. 25 raised to power 1 over 2 is square root of what? 25, and so on. So once we have the power to be 1 over 2, then it's just square root. Because if you put 1 here, when you raise a number to power of 1, there will be no change in that number. You will still obtain the same number. 9 raised to power 1 is 9. 4 raised to power 4. Sorry, 4 raised to power 1 is 4. 25 raised to power 1 is also what? 25. Okay. So I think this is very clear. This is very clear. So let's take a second example. Example 2. Let's take a second example. Example 2. You know, we are starting with the elementary examples before we now increase it to harder questions. We're going to increase it to harder questions. So if we have simplified 27 raised to power minus 1 over 3, okay? We have to introduce this so that we'll see a case where we have a negative power. So let's solve this together. The solution to this. What's the solution to this now? 27 raised to power minus 1 over 3. Now the same principle that we use will also be applied here. So we have taken note of the term or the expression, we have taken note of that. Use appropriate rule or law to remove the negative sign on the power. We are going to use this step too, because we have a negative sign on the what? On the power. We have a negative sign on the power. And in one of the rules in fractional indices, we have this. And we say that this is something as 1 over a raised to power m over n. Remember, I asked you to make notes of that those rules that we gave in the last video. Just copy it out somewhere so that when you become confused at any stage, you can actually consult the rules. So we are going to transform this. We need to remove the negative sign. And when we do that, we have 1 over 27 raised to power 1 over 3. And it's beautiful now. So since we have done that, we say write the term in root power form. So let's write this in root power form. This is going to be 1 over cube root of 27 raised to power 1. Right? Cube root of 27 raised to power 1. So if we evaluate the power first before the root, 27 raised to power 1 is 27. So we just have 27. 27 raised to power 1, 27. We have not touched the root. Right? We know why we have this cube root, because of this 3. Remember, in fractional indices, the power is the numerator, while the denominator is the root. So finally, we can have 1 over, what is cube root of 27? Is 3. Cube root of 27 is 3. So 27 raised to power minus 1 over 3 will give us 1 over 3. 1 over 3. Okay? That's also good. Okay, we take another example. Yes. We take another example, example 3 now, the third example. We take the third example, example 3. So let's see another example, example 3. Simplify 0.125 raised to power 2 over 3. You have this. Simplify this. 0.125 raised to power 2 over 3. Okay? Now, somebody is already shouting. If you don't understand certain principles in dealing with this, you will start shouting immediately and say, where is this decimal coming from? Don't worry, you'll see how we'll handle it. It's not a difficult task. So 0.125 raised to power 2 over 3. So how do we handle this? Number 1, whenever we have decimal fraction, we have to change them to vulgar fraction. So we have a decimal fraction here. So we'll write it in this form. In this form, yes. This vulgar fraction. So if we do that, 0.125 raised to power this, I can write it as 125 over 1000. Now raised to power 2 over 3. So that's what it means. That's what it means. From basic mathematics, you know how to change decimals to what? To fractions. So 0.125 raised to power 2 over 3 is the same thing as this. Okay? Now, if we go further with this, we can check this and discover that we can actually reduce it to lowest term. Yes, you can. You can reduce it to lowest term, because by the time you start dividing, 125 over 1000 will give me 1 over 8. You can try that. So I can reduce this to lowest term. It is still possible that if you cannot reduce it to lowest term, you can still evaluate it from this point. Yes, you can still do that. Maybe after solving this now, we'll get to that. For example, here 125 over 1000. We know if we start dividing by 5, we are going to have 25. If 5 divide this, we have 200. If 5 divide this is 35, 5 divide this is 40, 5 divide this 1, 5 divide this 8. So by reducing this to lowest term, we have this. But if in a situation you cannot reduce it to lowest term, you discover that maybe the numerator and the denominator, they don't have common factors, just like here they have common factors. But if the numerator and the denominator, they don't have common factors, what are you going to do? You evaluate without reducing to lowest term. So let's continue. So we now write this in root power form. We'll write this in root power form. We have taken note of this, and when we took note of this, we discovered that there's going to be a stumbling block. Excuse me. There's going to be a stumbling block because of the decimal. That's why we have to change it to fraction. So in root power form, this is going to be cube root of 1 over 8 excuse me, to power of what? To power of 2. This is the root, this is the power. So this will give us, we evaluate the root first before the power, or the power first before the root. So let's evaluate the root. What is cube root of 1 is 1. What is cube root of 8 is 2. We just evaluated the what? The root. So this is gone because we have handled this. Cube root of 1, cube root of 8, 2. So this root is done. We remove it because it has taken care of itself on these numbers. So raised to power 2, we are here to handle power. So this will now give me 1 raised to power 2 is 1. 2 raised to power 2 will give us what? 4. So the whole of this is 1 over 4. But one can also evaluate this directly from here without reducing to lowest term by saying, writing this as cube root of 125 over what? Over 1000. Cube root of 125 over 1000, all raised to power what? 2. So if you find cube root of 125, you will have 5. If you find cube root of 1000, it is 10, all raised to power what? 2. You can decide to now reduce this to lowest term. You have 1 over 2 raised to power 2, which is this, and you get your what? Your answer. Alright, I'm going to leave you with just one question so that you can enjoy it, and when we return, we are going to solve more examples on what? On fractional indices. We're going to solve more examples because it is question galore now. We have so many questions to solve, but you have to take down this particular question as takeaway question. So let's look at this. So we have takeaway question. One simple question like that. So simplify 0.027 raised to power minus 2 over 3. So simplify this. Very simple. You know, we have not really started the main questions on indices. These are the preliminaries. It's just to lay foundation before we now begin to scale it up. Alright, thank you for watching our videos till now. In the next video, we are going to do correction to this takeaway question, and then we'll solve further problems or further examples on what? On the concept of fractional indices. Remember, I'm still your friend, your tutor, and your brother. Yeah, I'm still your brother. Engineer Iko Kichku is my name. I love you.